Our planet is wrapped in a blanket of air. This atmosphere, an immense and invisible ocean of gases, is fundamental to life as we know it. It provides the oxygen we breathe and shields us from harmful solar radiation. We exist at the bottom of this ocean, its weight pressing down on us with a force we rarely notice. This pressure is the baseline condition for nearly every biological and mechanical process on Earth, a constant that has shaped evolution and engineering. Imagine then a scenario where, over the course of a single year, Earth loses 5% of its atmospheric mass. This is not a cataclysmic event. It is a subtle but profound alteration, a global shift not immediately obvious to the naked eye. Losing 5% means that over 257 trillion tons of air would vanish. The consequences would ripple through every aspect of our existence, from the weather patterns to the engines that power our modern civilization. We will trace the chain reaction, starting with the initial subtle physical changes and following them as they ripple outward. The change would be registered not by human senses, but by sensitive scientific instruments. Barometers worldwide would record a steady, synchronized drop. A lower atmospheric pressure means water will evaporate more readily. That alters the planet's water cycle, changing rainfall patterns and humidity levels. The atmosphere's mass provides a crucial buffer. A 5% thinner atmosphere equals a 5% less effective shield. More of the sun's harmful ultraviolet radiation would reach the surface, potentially damaging the DNA of plants and animals. The planet's ability to retain heat would be diminished. The greenhouse effect would weaken, leading to slightly cooler nights and altered temperature gradients. Plants breathe through tiny pores called stomata. To compensate for less CO2, many plants would have to open their stomata wider or for longer periods. This compensation strategy would come at a great cost: water. Plants would lose more water to the drier, thinner air, increasing their vulnerability to drought. Crop yields would be among the first casualties. Staple grains like corn, wheat, and rice would see their efficiency drop, producing less grain. This widespread botanical stress would trigger a domino effect. Herbivores would find their food sources diminished, impacting predator populations in turn. The thinning atmosphere would quickly expose hidden vulnerabilities, starting with aviation. Aircraft rely on air density for lift and engine performance. Planes would require longer runways and would have to reduce passenger numbers or cargo weight. Engine performance would also degrade significantly. The problem would extend to power generation. Cooling towers use ambient air to dissipate waste heat, but thinner air is less efficient at heat transfer. This would create instability in energy grids and a drop in power for heavy machinery, slowing down construction, agriculture, and the movement of goods. The health impacts would not be distributed evenly. Vulnerable populations would face chronic medical distress as it becomes harder for lungs to absorb oxygen. This air gap would become a new form of global inequality. The wealthy could afford to retrofit homes and relocate, while poorer communities would bear the brunt. As regions become less habitable, migration pressures would build, creating a new class of atmospheric refugees. The global economy would enter a period of prolonged instability, characterized by food scarcity, inflation, and a retreat from the interconnectedness that defined the early 21st century. Humanity would be forced to adapt, forging a new, more challenging existence. New engineering standards, agricultural practices, and aviation norms would emerge. The crisis spurs innovation. Global monitoring systems, far more sophisticated, would watch the atmosphere with unwavering vigilance. Architecture evolves, with buildings becoming active life support systems. Supply chains are redrawn, prioritizing regional resilience over globalized efficiency. The final state is not one of collapse, but of costly adaptation. The sky, a slightly darker shade of blue, would serve as a permanent reminder of the crisis. We would continue on, a civilization that has looked over the edge and pulled back, forever changed by the knowledge of how quickly the world can be remade by a change in the air. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.